Hello Calculus 1 students. Today we're going to look at the solutions for the sample final for Math 175. So in this video we're going to begin with problems number 1 and 2, and hopefully I can do at least 2 problems per video. So for problem number 1, we're computing the derivative dy over dx for y equals the square root of 5 plus x to the 5th over 5 minus 5 times ln of x. So in this problem here, we're just finding the derivative of y with respect to x. So you could write dy dx, or you could have wrote y prime. Either one is fine. So what we're going to have is the following. We're going to have that y prime is going to equal to, well, let's take the derivative of square root of 5. Well, since the square root of 5 is a constant, it's a number, then when you take its derivative, that's going to become 0. If you take the derivative of x to the 5th over 5, you're going to be applying the power rule. So you bring the 5 down, and then subtract 1 from its exponent. So that would be 5x to the 4th over 5. And now finally you take the derivative of 5 times ln of x. So if you can recall, the derivative of ln of x is 1 over x, and since I have this negative 5 in front of it, it's going to be minus 5 times 1 over x. And now simply I can just simplify my derivative. We're going to have that y prime is going to equal to, well, 0, that just goes away. 5 over 5, that is cancelled. So you're left with x to the 4th. And now it's going to be minus 5 over x, right? Negative 5 times 1 is negative 5 divided by x. And that's it. That's just finding the derivative of y with respect to x. So there was 3 important rules. Derivative of your constant is 0. You're applying your power rule where you bring down your exponent and then subtract 1 from the exponent. And here, the derivative of ln of x is simply 1 over x. So in problem 1, you're just using basic derivative rules. Okay, on to problem number 2. It states compute the derivative p prime of y of the function p of y equals 2y plus 3 divided by 7y plus 5. So in this problem, because we want to find the derivative of your function p, you're going to need to use your quotient rule. So just recall that the quotient rule states the following. If you're trying to take the derivative with respect to x of one function over another, right, u divided by v, then this is simply going to be v times u prime minus u times v prime, all divided by v squared. So we can go ahead and label what will be our u and v, find our derivative of each, and just plug it into this formula. So let u be the function that's in the numerator, so that will be 2y plus 3. And you know that v is going to be 7y plus 5. So all you need to do is just find the derivative of both, and then we can just apply our formula. So we're going to get that u prime is going to equal to, well, take the derivative of 2y plus 3, that's going to be 2. Take the derivative of 7y plus 5, that's going to be 7, since the derivative of, of 5, your constant, is going to be 0. So now that we have our functions and their derivatives, just apply our quotient rule. So p prime of y is going to equal to the following. You're going to have v times u prime, so it's 7y plus 5 times 2, minus u times v prime, so it's going to be 2y plus 3 times 7 over your denominator squared. So your denominator was 7 y plus 5 squared. And now finally you can simplify this. While you're simplifying it, just remember that you can leave your denominator squared. So let's see. 7y plus 5 times 2, I can distribute the 2 inside the parentheses. That'll give me 14y plus 10. Now here I have negative 7 times 2y plus 3. So if I take the negative 7 multiplied by 2y, that gives me minus 14y. And then negative 7 times 3 is negative 21, divided by 7y plus 5 squared. And now you just simplify this. You'll see that the 14y's, because you have one positive, one negative, they'll just cancel each other out. 10 minus 21 is negative 11. So you're going to have negative 11 over 7y plus 5 squared. And again, that will be the derivative of p of y, your function. And that's it. On to problems 3 and 4 in the next video.